All right, so we're here for part 3, and we're going to do an Algebra 2 introduction, something called completing the square. And I'm going to scan down here to number 17 and 18, and it says for each circle with the given equation, state the coordinates of the center and the measure of the radius. Well, the problem is that this is not written in what we call HK form. They give us x squared, y squared, there's an x and a y equals some number, but the problem is that is not in the form x minus h squared plus y minus k squared equals the radius squared. So we've got to do something with these values to get it into this form. One thing about x minus h, that's what we call a binomial, and when you square it, we multiply it by itself. And then the same thing with y minus k. If we were to multiply it out, we would get something like this. So the question is, how do we go from this back to this? So we're going to come back to the top here. Now we're going to start with an Algebra 1 review. How do you multiply x plus 5, that binomial, squared? Well, I'm going to write it out as x plus 5 times x plus 5. When you square, you multiply by itself. Now you may have been taught FOIL, first, outside, inside, last. What I call it is double distributing. Double distribute. Because what I'm going to do, I'm going to take the x in the first parentheses and distribute it to both values in the second set of parentheses. X times x is x squared, x times 5 is plus 5x. But then I have to distribute the 5 here to both numbers in the second parentheses. Plus 5x, 5 times 5 is 25. Now what happens is you get the same middle term. You get 5x twice. So when we combine that, that's x squared plus 10x plus 25. And that is what we call a trinomial, and it is a perfect square trinomial. That is what we get from squaring a binomial, 2 terms. Tri means 3, 1, 2, 3 terms. So if we square the binomial x minus 3, again, I'm going to write x minus 3 times x minus 3, and now I'm going to double distribute. X times x is x squared, x times negative 3 is negative 3x, then I distribute the minus 3, so it's minus 3x, and a negative times a negative is positive 9. Notice again, your middle term is the same, so there's 2 of these. We can combine that, we get x squared minus 6x plus 9. So again, that's a perfect square trinomial. Now what we're going to do here, I'm going to teach you a process called completing the square, which is where we go from here back to this, back to the original, from here back to this. So directions make these perfect square trinomials. X squared plus 8x plus something. What does that number have to be to make this a perfect square trinomial? Well, remember that the middle term comes from having the same thing twice. So I'm going to work backwards here. I'm going to take the 8 and think, what's half of 8? I'm going to divide by 2. So it must have been 4x and 4x. And to get this last term here, the 25, it was where I multiplied the 5 and the 5. Or I multiplied negative 3 and negative 3. So I'm going to take this number here, 4, and I'm going to multiply it by itself, or what we call squaring. 4 times 4 is 16. That's a perfect square trinomial because I can factor that to x plus 4 times x plus 4. But an even easier way to write it is x plus 4, parentheses, squared. That's what I want. That's what I'm trying to do, to take this to make this. So I divide by 2. I take half of that because I have 2 of them. Take half of that and then square it. So half of 4 is 2, so it's like a 2x and a 2x. 2 times 2 is 4. Now the binomial is x plus 2 squared. Half of negative 10, so it must have been negative 5 and negative 5 in the middle. When I square negative 5, I get 25. So that's the perfect square trinomial. The binomial factors are x minus 5 times x minus 5, which is x minus 5, that whole quantity squared. Half of negative 14 is negative 7, and negative 7 times negative 7 is positive 49. There's my trinomial, and so the factors are x minus 7, parentheses, squared. So you may be asking, why are we doing this? Well, in the equation of a circle, I need binomials squared. So if I can get binomials squared, I can say something about the center of the circle. Okay, so in 17, here's what we're going to do. First thing is I'm going to rewrite this with the x's together. So I'm going to say x squared minus 4x plus something. I don't know what that is yet, but I'm going to find it. Then the y squared plus 2y plus something equals 4. And then I'll come back to that in a second. So we're going to complete the square with the x's. Take half of negative 4, which is negative 2. And if you square that, what we get is positive 4. And then for the y's, take half of 2y, which is 1y, and 1 times 1 is 1. Okay, now there's one other thing I need to do in the equation. I just added 4 and 1 to the left side of the equation. Whatever you add to one side of an equation, you have to add to the other side. So if I'm going to add 4 and 1 to the left side, to balance, I need to add 4 and 1 to the right side to keep things equal. Okay, now what I do is I'm going to factor, because this is a perfect square trinomial. That was x, and then it's minus 2, parentheses squared, plus, this is a perfect square trinomial. I can factor that, that's y plus 1 squared, equals 4 plus 4 plus 1 is 9. And now what you have is the equation of a circle. Now I have my h and my k. So the center is positive 2, negative 1. Remember, it's the opposite of the numbers you see in the parentheses. And then the 9 is your r squared. So if the radius squared is 9, that means that the radius has to be 3, because I square root that to solve it. Okay, so we're using this concept of completing the square to get this into a form that allows us to make conclusions about our circle. And if you wanted to graph it, you could. All right, so let's do 18. So again, I'm going to organize my x's first. X squared minus 16x plus something. I'm kind of looking into the future and seeing I need to add something to make this a perfect square trinomial. Now the y squared is by itself. So actually, I don't need, since I don't have another y term, I'm going to keep this like it is, equals negative 48. But whatever I add to the left side, I have to add to the right side. So let's figure this out. Negative 16x, divide that by 2. So it's negative 8x and negative 8x. And negative 8 times negative 8 is positive 64. Again, we don't need to put anything there. Technically, that's like y minus 0 squared. That's already in a good form for us. But on the right side, we have to balance. So whatever I do to one side, if I add 64, I'm adding 64 here. Okay, so this is a perfect square trinomial. That's x minus 8 squared plus, that's just y squared, equals 16, which is nice because that's a perfect square. The center is positive 8, and for the y value, that's 0. So the center is at 8, 0. Now your r squared is 16, so the square root of that, the radius is 4. And that's it. Okay, so that is called, this technique is called completing the square. You'll see this more in Algebra 2, but it's actually not that hard. It's just how do we take this equation and put it into our form for the equation of a circle, which allows us to say something about the center and the radius. If we can get it into HK form, it just makes it easier. And that's the end of part 3.